Welcome back to my channel. What I have for you today, you see, I have something that is quite important, and let me say something so much interesting to explain to you today. You see, what we are going to be doing today is all about Jamb series, chemistry Jamb series. Now, the question that I've been asking a lot of students, or let me say the question that I'm asking a lot of students, is that why is it that many students in Nigeria failed Jamb? Actually, this year's record in Jamb says that millions of students get below 200 in Jamb, and their major problem is their chemistry, physics, mathematics, biology. Now, today's class, I'm going to be dropping the question to you. Why is it that many students failed Jamb? Is it because Jamb is getting difficult every time, or let me say every year, or the students are not reading, or is it because that the exam itself looks somehow? This thing is the reason for that. The major reason for students failing Jamb was not because Jamb is getting difficult, and it wasn't because the students were not reading. A lot of Nigerians are reading a lot. They are reading all day and night, but still yet they fail to read the right thing. Now, many students read a lot, but they are not reading the points. In studying for Jamb, in scoring 360 in Jamb, that's what we know what looking. Sorry, they let me what they said that in scoring above 300 in Jamb, that's what look at. How do we score above 300? It is possible to score it. Actually, I also did the same thing because I score above 300 in my Jamb. So to do that, it is quite easy for you to do. How did I do mine? It is for me to read, but to read the right thing. So today I'm going to be taking you through different series of how Jamb asks their question in chemistry. Now, we are going to be looking at each topics in chemistry and what you should expect. So please don't forget to follow up with this my Jamb series, and also please try to subscribe to my channel and like my video, because your like and your subscription means a lot to my channel. Please don't forget, and also click on the notification bell to receive the new notification whenever I release any video. Now let's get started. Today we're going to be looking at the topic separation techniques. What is separation techniques? Now, what are you expected to understand in this separation technique? Separation technique simply means the means of separating two or more mixtures that are physically combined together. Now, how do we separate mixtures that are physically combined? These one may physically combined. For example, now I have a mixture of sand plus a mixture of salt. Now, these two substances cannot mix together with each other. It is impossible for them to mix. All together. Now, sorry, they cannot react with each other, not mix. They can mix together with each other, but they can't react with each other. Are we together? Now, you see, these two substances, the reason why they cannot react, let's say because one of the reasons is that they vary in physical property. Oh, actually they are both solid and solid, but the solid nature of this is different from this based on the size of the particles. Are we together? Now, let's now look at these two substances can easily be separated. Why? Because they are not joined together chemically, they are only joined together physically. Now, we are going to be looking at in separation techniques. What are the, you see, every mixture are always separated using some physical property. Physical properties of the like, let's say, the following physical properties are used in separating mixture. Please note that. Number one, we make use of the physical states of the mixture. Now, when we're referring to physical states, I'm talking about the solid state, the liquid state, and the gaseous state. So, two or more mixtures can be separated using their physical states. Now, number two is that we can use their polarity to separate them. Number three, we can use their density density. Number 4, we can use their solubility. Solubility. Number 5, we can use their color to separate them. Then we can separate using what? Color. And number 6, we can also use their boiling points or their melting point to separate 2 or more different mixtures. So we are going to be looking at each of these properties and what kind of separating techniques can be employed in what? Separating any mixture like that. Now, let's take from the start. Now, you see, in chemistry, we believe that mixtures are divided into different kinds. But for Jamb, what they expect from you in Jamb is for you to understand the different kind of mixture that we have. In my next video, you will understand different kind of mixture that we have in chemistry. Actually, we should have a solid liquid mixture, a solid liquid mixture. We have a liquid mixture, and we also have a solid mixture. Now, these are the 3 types of mixture that questions are often asked in Jamb. They always ask students, based on these 3 types of mixture, what are the separating techniques that can be used to separate each of these? And sometimes they ask you that what is the physical property that is used in separating such a mixture? Are we together? Now, let's take it from the start. Let's take solid and liquid mixture. You see, solid and liquid mixture, if I have a solid and liquid mixture, any solid and liquid mixture, whereby the solid is serving as the solute and the liquid is serving as the solvent. So whenever a solid is dissolved in a liquid, are we together? The following separating techniques can be employed to separate it. Number 1, we can use filtration. Filtration can be employed. Number 2, we can employ crystallization. Crystallization can be employed. Number 3, we can use evaporation to dryness. Evaporation to dryness. Number 4, we can also use decantation to separate them. Number 5, we can use evaporation to dryness, decantation. Yeah, let's go for it. Yeah, you can also use centrifugation to separate the mixture. Now, what are the properties that each of these things are used in separating? And what kind of separation? What is the major question I want to ask under this in Jamb? Now, the filtration itself, it can be used to separate 2 or more substances that are insoluble in each other. Now, that means if the solid particle is insoluble in the liquid, then we are going to separate them using filtration method. What do you mean by solubility? Soluble simply means the substance should be able to dissolve in the liquid. Let me give you a great example. You see, salt is always soluble in water. What does that mean? Simply means if I pour salt in water, it is going to dissolve in water. So, separation of salt and water, since that these 2 things is going to dissolve, cannot be separated using filtration. Filtration cannot be used to separate the mixture of salt and water. Why? Salt will dissolve in water. So, what are the major these things that we can separate using filtration? The following example are examples that can be separated using filtration. Let's take, for example, we have suspended particle in liquid. Don't forget that example of a suspended particle in liquid is muddy water. Muddy water is an example of suspended particle in a liquid. So they can be separated with filtration. Why is it like that? It is because the density of the particle the particle in water, in that muddy water, is an example of sediment. Yeah, that is what? That is sediment. Now, another example is that sediment in a sample of water can also, I think this is the same, it looks like so. Sediment in a sample of water can also be separated using filtration, and also saturated solution in contact with undissolved solutes using filtration method. Now, what is not the major point that is there? You see, filtration method can be used to separate an insoluble solid. An insoluble solid. That means a solid that is insoluble in water or in a liquid. All together. And also, that solid must be of low density. That means it must not have it must not have weight. Let me give you an example of density. You can compare the heaviness of stone with chalk particle. So we notice that chalk particle is of lower density because it is not that heavy compared to stone. So if you have a substance of lower density, you can separate them with what? Filtration. Actually, with that same insolubility, we can also separate using decantation. Decantation is a separating technique that is also used to separate two mixtures that are also insoluble in each other. That means it can be used to separate a solid and liquid, whereby the solid is insoluble in the liquid. But one of the major differences between decantation and filtration, since both of them are what? For insoluble solid, the major difference between them is that decantation is only used for a solid with high density. A solid with high density. Example of decantation. Decantation, you can separate sand particle from what? The mixture of sand particle and water can be separated using decantation. Hope we're together. That's an example of decantation. Now, let's look at what about if the solid is now soluble in the liquid. For example, you see, if a solid is soluble in liquid, we can employ this method for separation. Crystallization and evaporation to dryness can be used to separate two substances that are soluble. That means, let me say, can be used to separate a solid that is mixed with a liquid in which the solid is soluble in that liquid. Are we together? Let me give you an example of solid. As I said earlier that if salt is dissolved in water, you will not know the difference between salt and water. I can only see the salt particle. The salt particle will not be seen inside the water. The only thing that you can use to indicate that this mixture contains salt particle is only the taste. So if you have two mixtures that are mixed, if you have two substances that are mixed together, whereby they are soluble in each other, then we can separate them using crystallization or evaporation to dryness. But they also have their own separation method. What is the separation method? Don't forget I said the separation method for this and this is their what? Insolubility. For decantation, it is the what? Density. It is making use of density to separate. Don't forget I said a substance that is of high density will what? Settle on the floor, while the one with of low density will be able to decant the water away. So it is making use of density. Now look at these two things here. Crystallization and evaporation are used to separate two mixtures that are what? Soluble, as I said earlier. Now, how do we now do that? You see, for soluble mixture, for example, evaporation to dryness can be used to separate a mixture in which the solute is of high melting point compared to the boiling point of the liquid, of the solvent. That means a solute that is of high melting points, compared to the boiling point of the solvent. For example, a mixture that is separated with evaporation to dryness, the solute must be of high melting point, while the solvent must be of what? High boiling point. But the melting point of the solute must be bigger than the boiling point of the solvent. For example, now, you see, evaporation to dryness, let me give you two soluble mixtures that we know. We know that normally salts Salt plus water. Salt is always soluble in water. At the same time, sugar solution. Sugar solution. In sugar solution, sugar is soluble in water. But what is the difference? What is separating techniques that can be used to separate this? These two are soluble mixture. But the problem that the same separating techniques cannot be used for both. For salt solution, salt has high melting points, while water also has what? High boiling point. But the melting point of salt is more than that of what? Water. It simply shows that when you heat solution of salt and water, salt will never decompose on heating. So any substance that will not decompose on heating can easily be separated using evaporation to dryness. Please don't forget, we are making use, what is the property that is used in separation and evaporation to dryness? It is the boiling points. The boiling points. The boiling points. All together, that is what we are using to separate here. We are using the boiling point and the boiling point of the solvent and the melting point of the solute. Don't forget I said the solute must be of high melting point, while the solvent is of what? Also what? High boiling point. So we make use of the boiling point to separate in what? Evaporation. That is the property that is employed there. Now, the second thing is crystallization. I said also, crystallization can also be used to separate a soluble mixture. Now, when a solid is soluble in liquid, we can also use what? Crystallization. But crystallization can only be used to separate a mixture, a soluble mixture that is of, let me say, okay, for example, mixture of sugar and salt, sugar and water can be separated using crystallization. Now, you see, in crystallization, what is employing is trying to also employ what? The melting point. Just that we can only use crystallization to separate a substance that will decompose on heating. It simply shows that it does not require more heat compared to evaporation to dryness. So, crystallization can be used to separate a substance that will decompose on heating. Altogether, so in that case, the substance they want to separate has the melting point of that substance is lower than the boiling point of water. Sugar and water. Sugar has lower melting point than the boiling point of water. So sugar solution can be separated using crystallization to crystallization. Please, you'll be asked each of these properties. I said something now of boiling points, that the property that is employed in evaporation to dryness and in evaporation to dryness is the boiling point. While the one that is employed in this one is the melting point of the what? Of the solute. Now, the next thing that we can also separate, we can also use, you see, all these ones, crystallization and evaporation, can be used to separate a single solid from a liquid. Altogether, now, we can also use fractional crystallization. Fractional crystallization. That is another method that is used to separate a soluble solid from what? Its liquid. Fractional crystallization. Fractional crystallization. Fractional crystallization is also another method that can be used to separate a soluble solid. Let me take it like this. Let me take it in this manner. For solid and liquid that are soluble, for soluble mixtures of solid and liquid, we can employ evaporation to dryness. We can employ crystallization. We can also employ fractional crystallization. And also, we can also employ, we can use this also, precipitation. I forgot to write it out before. So we can use precipitation. At the same time, we can also use simple distillation. Please follow up with me very well. We can use all this, but how do we separate using all these methods? Now, I've explained to you about evaporation. I've explained to you about crystallization. Now, what about fractional crystallization? fractional crystallization is the process whereby two or more solids are crystallized one after the other in the same solvent in which they are both soluble in it. Now, just that in fractional crystallization, we have two solids. Two solids are soluble in the same solvent. So, but the problem there is that one solid is more soluble than the other. One is least soluble, while the other is what? More soluble. Let's take for example now, we know that what? Sodium chloride is what? Highly soluble. Sodium chloride is highly soluble compared to calcium chloride. All together. So one solid is more soluble, while the other one is what? Least soluble. Now the major problem is that what? The least soluble solvent, the least soluble substance crystallizes first, while the other one is left behind. All together. Now, what is the physical property that is employed in fractional crystallization? The physical property that is employed in this fractional crystallization is difference in solubility of the two solids. Difference in solubility of the two solids in the solvent. That is what it is employed here. Now, let's go on to precipitation. Precipitation can also be used to separate soluble substances altogether, but in this case here, the two solids are soluble in the same solvent. Altogether, they are both soluble, they are of the same, their solubility is the same in the same solvent. So we can separate this, using precipitation by adding another solvent in which one of the solids is insoluble in that solvent. We can separate them like that. So if we add another solvent in which one of the solid is insoluble in it, then the insoluble one will be what? Removed. Why the soluble one will be what? Removed. Why the insoluble one will be what? Left inside. So the process of doing that is what? By precipitation. Precipitation is employing what? The insolubility of two different solutes in a single solvent. That is what it's employing. Another method of what? Separating a solid liquid mixture that are soluble is by making use of simple distillation. Simple distillation is used to get a solvent from its solution, unlike evaporation to dryness. Please note, in evaporation to dryness, it is used to get a solute from its solution, whereby the solvent will what? Evaporated. But to get the solvent and also the liquid, I want to get the solvent and the solute. We can only employ simple distillation. So simple distillation is used to what? To get a solvent and what? The solute. Now, in simple distillation is simply applying the boiling point. That is the property that is applying in separation of that of the mixture. So it is employing the what? The boiling points. Boiling points. That is what it is using, the boiling points. Now, other separating techniques that can be used to separate a mixture that are kind of soluble in each other. We can separate using centrifugation. You see, centrifugation majorly are used in separating colloidal dispersion. Don't forget that colloidal dispersion is not a true solution. That means if I want to separate the cell from the blood, we can use what? Colloidal dispersion to separate the blood from the what? From the cell. Altogether. Now, the method that is used in what? In separation is the difference. It is using the what? Centrifugation is making use of what? The difference in the rate of sedimentation. So centrifugation is using the what? The method that is used to separate is what? Difference in rates of sedimentation. You know, in this kind of what? Separating techniques, the two mixture, let's say for example, we make use of this in the laboratory. The two mixture, the blood itself and the cell itself, they are placed into a centrifugation machine. So when they run the machine, after some time, the blood will separate itself from this thing. It should now form a kind of a segment. One will levitated upward, while the other one will be at the bottom. Then we can easily remove the sediment away from the mixture. Are we together? That is by using centrifugation. So you see, this method that I've given you are all used in separating a solid from a liquid, and with the previous one given to you, we can use them to separate a solid from a liquid. Now, let's have a look at when we have a kind of solid mixture. What are the separating techniques that will be employed when you have a solid mixture? If I have a solid mixture, if two mixtures are solid and solid and they mix together, you can easily separate them using the following separating techniques. We can use sublimation to separate. Number two, we can use magnetization to separate. We can also use sieving method to separate. We can use sieving method to separate. We can also use flotation method to separate. We can use flotation method to separate. Now, before I move on to this, I need to attempt a question at the end of the class. Now, sublimation, magnetization, sieving, and flotation. Now, what do you mean by sublimation? Sublimation simply means the process whereby a solid turns into a gaseous state. Now, all solid that sublime does not have a single. They are not liquid at atmospheric pressure. That means they don't pass through a liquid state at their atmospheric pressure. Example of solid that you know that they can sublime. Let me give you an example. These are, number one, example of solid that will sublime. We have camphor. Camphor is an example. Number two, iodine. Number three, we have ammonium chloride. You see, all these solid, whenever they are mixed whenever they are found in any mixture, they can only be separated using sublimation. Please note, these are the major solid that you'll be given in Jamb that you test your knowledge on. They're going to test your knowledge on this solid when it dissolves. Please note that. So sublimation is used to separate a substance that will sublime on eating. So when you eat all these solids, when you eat them, they don't pass through the liquid, the gaseous state. So we can separate them using sublimation. All together. Now we can also separate a liquid and two different solids that are mixed together using magnetization. What is magnetization? You see, this one is making use of magnetic property of one substance from another. Magnetic properties of the substance. Now, for example, magnetization can be used to separate two solids in which one of the solid is magnetic in nature, while the second solid is non-magnetic. Now, for example, if iron filling plus sand particle. That means if iron filling is mixed with sand particle, then these two mixtures can easily be separated using magnetization. Why? Iron filling is magnetic in nature, while sand particle is non-magnetic. Now, we can also use sieving to separate. Just that sieving is used to separate when you have two particles of different density, or let me say, two substances of different density. We can separate them using sieving. For example, now you have the mixture of sand, and let me say, sand and salt, for instance, or let's say, So you see, if you have this sieving is employing size of particle to separate. it makes use of the size of particle. For example, now you see one of the major applications is that maybe in all these in Nigeria, normally we can separate dust away from our base. We can separate the dust particle away from our base, and also in making pap in Nigeria, we can separate the shaft away from the pap. So we can only do that by using the process of what sieving. We use what you sieve. That is one of the major these things. So in sieving, it is employing the size. The thing that is employing there is the size of the particle. That's what we are using to separate. That is the physical property that is used in separation. Now we also have what flotation. Flotation, you see, flotation is also used in separating two different solids. But the major problem is that in flotation, the two solids are of different size. Just that the size that we are referring to in this place is bigger than the size of this. Just let's take for example now. We have a sand particle that is mixed with chalk particle. Sand plus chalk particle. Sand and chalk particle. The size of the particle here, the size of the particle of sand is bigger than the size of the particle of chalk. We can separate these two things using flotation. How do we do that? We dissolve both of them inside water. This one is going to settle at the bottom, while this one will float at the top. So these two things can be separated using flotation. I hope you're following up with this night class. Please, anyone you don't really understand here, please drop a comment in the comment box below. I'm going to return to your comment and I'm going to answer you. Now, let's continue. Now, let's take a look at this is for solid. These four different separating techniques can be used. Sublimation, magnetization, sieving, and flotation can be used to separate two or more different solids that can mix together. Now, let's now look at if we now have liquid mixture. I think that is another one that is quite important that is asked often in Jamb. Liquid mixture. Now, let me give you an example of liquid mixture. I can have a mixture of alcohol. Alcohol in water. If alcohol is mixed with water, this is an example of liquid mixture. And also, we can have a mixture of, like for example, your crude oil. Your crude oil is a mixture of different liquids. We have petroleum, we have diesel, we have gases, we have all these mixtures are what? That kerosene is also found in our crude oil. All together. Now, these are liquid mixture. But how do we now separate? What is Jamb going to ask you based on this liquid mixture? That is why you need to follow up with me. Now, in this liquid mixture, a miscible liquid and an immiscible liquid. Now, the liquid can be a miscible liquid, miscible liquid, and what? Immiscible liquid. Immiscible liquid. Now, we can have a miscible liquid and what? Immiscible liquid. What do you mean by miscible liquid? Miscible liquid are liquid that will mix with each other. Altogether, liquid that is going to mix with each other, that's what we call what? Miscible liquid. While immiscible liquid are liquid that does not mix with each other. Altogether, sorry. Immiscible liquid are liquid that does not mix with each other. For example, now let me give you an example of immiscible liquid. Now, if you dissolve water, if you add water plus kerosene, these are two different liquids. Water plus kerosene, or water plus any crude oil, maybe oil, or your groundnut oil, or your red oil. If water is mixed to them, they will never mix. You notice that water will be at the top. Water will be at the bottom, and that kerosene will be at the what? at the top. This kind of liquid is what we call what? Immiscible liquid. Example of miscible liquid that we have is a mixture of, the crude oil, like kerosene dissolve in kerosene. Kerosene dissolve in petrol. Kerosene can dissolve in oil. Red oil will dissolve in what? Normal oil. All together, all these are miscible liquid. What is now the separating technique that is employed for separation of miscible liquid? Now, miscible liquid can be separated using a separating funnel. Separating funnel. That is what we make use of in separating immiscible liquid. Immiscible liquid are separated using a separating funnel. That is immiscible liquid. An example of this immiscible liquid that I just said earlier on is the mixture of kerosene plus water is an example of immiscible liquid. So this immiscible liquid can be separated using what? A separating funnel. Now, what is now the physical property that is employed in this separating techniques? The physical property that is employed in this separating techniques is the polarity of the solvent. The polarity of the solvent. Now, there is a rule of polarity in chemistry. You see, the rule says that what? A polar substance will dissolve in an polar substance, while a non-polar substance will dissolve in what? A non-polar substance. Now, let me give you one thing here. Water and kerosene will never dissolve because water is a polar solvent, while kerosene is a non-polar solvent. So since that they are different polarity, they will not dissolve in each other. So you can separate them using separating funnel. So for any substance that will not dissolve different in polarity, they will separate using a separating funnel. Are we together? Now, another thing that we now have is what? How do we now separate miscible liquid? I've given you an example of miscible liquid. Now, let me give you it again. You see, in separating miscible liquid, we have two separation methods. The first one, we can use simple distillation also, just like in your solid and liquid. We can use simple distillation. Simple distillation can be employed, and we can also use fractional distillation. Now, in simple distillation, don't forget I said the property that is employed in these two distillation, anything that is distillation, it is employing the boiling point of the solvent. Altogether, the boiling point. But in this case here, we are trying to, the property that is employed here is the boiling point of the two liquid. Now, what kind of mixture can be separated using simple distillation, and what kind of mixture can be separated using fractional distillation? Let me give you an example of this. We are getting to this point here. You see, a mixture that can be separated using simple distillation, we can use to separate a mixture of alcohol plus water. This mixture can be separated using what? Simple distillation. Why? Because alcohol, the boiling point of alcohol and water are far from each other. So simple distillation can be used to separate a mixture that has large variation in boiling point. So whenever a mixture has a large variation in boiling point, they can be separated using simple distillation. Example is alcohol plus water. So now fractional distillation, don't forget that it employs the same thing. See that they are distillation. Both of them, they are employing boiling points as their separation words. That's separating what the property that they are employing in separation is the boiling point. Now, fractional distillation can be used to separate two different mixture that has very close boiling points. Oh wow, this is kind of what's confusing a lot of students. You see, these two things are just kind of special. We normally make use of fractional distillation to separate two liquid mixture that have very close boiling points, and you can only have that in crude oil like kerosene, petrol, diesel, and the likes. All these things have what? Very close boiling point. So you can separate them using fractional distillation. So in industry, in all this what petroleum industry, they make use of what? A fractional distillating column to separate kerosene, petrol, and diesel away from each other. That is another what? Great method of separation. Now, don't forget, let's continue moving on. The third thing, or let me say the fourth thing, is that we want to look at color separation. Color separation. Now, what kind of separating techniques is employed in separating colors? Yeah, you know, I've given you the ones that I employ that are measured in liquids and solid. We also have the one that measured in separation of color. Now, the separating techniques that is used here in this separation is what? Can you guess? That is what we can employ chromatography. Chromatography. Actually, we have different kind of chromatography, but the major one that is using here is paper chromatography. That's what we are using. So, chromatography is used to separate color. That means a color, for example, now we can use to separate, like it can be employed in solid liquid. For example, in separation of dye and ink, dye and what? Ink. Are we together? So we can use to separate this. Now, also, for example, it can be used to separate color pigments away from leaf, like chlorophyll 2. That is one application. And also, it can be used to test if a food is contaminated. Yes. Chromatography can be used to test for what? To test if a food is contaminated. Please note that. Now, I said chromatography used in separation of colors. Just what we are using, what? Colors. Now, but you know something about chromatography. What is the property that is employed in separation? That means, what is the property that is employed using chromatography? The property that is employed looks somehow. We normally call it the chromatography makes use of the word absorption. Absorption. That's what it's using. That is the property that is using absorption. This thing looks like absorption, but it is not absorption. This is not absorption. There's no between absorption and absorption. Absorption simply means the clinging of a substance to the surface of a solid or liquid. That's it. That's what we call absorption. So you see, in absorption, it makes use of what? Chromatography makes use of the process of what? Absorption to separate two or more different mixture of colors. Are we together with me like this? Thanks. Now, you know, see, I'm going to be looking at some, like, let me say a few questions, like 3 questions that have been asked in previous year in Jamb from students on all these topics that we've just covered for today. Now, the first question I'm going to be employing today is the Jamb series remis. Jamb series remis is the first question I'm going to be employing. You can also get this in bookshop. Yeah, but if you can get in bookshop, we are going to be dropping our contact below that you can contact us for the books. Now, this book make everything easier for students by writing each question based on what content, chapter by chapter. Now, if you are reading on separating techniques, you are going to be solving only questions on separating techniques only. Chapter 1 will be based on separating techniques. No more than that will be given to you. So you can contact us for that, for this book. That is all for that. Now let's take some questions that have been asked previously in Jamb. Now, I have a question that is given to us in this place. A question is given to us here. They said, a small quantity of solid ammonia chloride was heated gently in a test tube. The solid gradually disappeared to produce a mixture of 2 gases. Later, a white cloudy deposit was observed on the cooler part of the test tube. The ammonium chloride is said to have undergone what? Don't forget I said whenever you have ammonium chloride, Ammonium chloride, whenever it is heated, it is going to sublime. So the option here we have A, distillation, B, sublimation, C, precipitation, D, evaporation, and E, decomposition. It is sublimation, while the ammonium chloride are simply sublime. Now, this one that question normally used to twist students' brain in Jamb. I think I got a question in this place here. It is when you have more than 2 mixtures. You are given like 3 different mixtures. How do we do that? For example, they said, I think I got this. Yeah, thank you. We said methanoic acid. I don't want to write it out. Methanoic acid with water. Sorry, methanoic acid mixed with water in all proportion and has the same boiling point as water. That is the major point there. The same boiling point as water. Methanoic acid is having the same boiling point as water. I've given you all the separating techniques. I didn't mention anyone that can be used to separate when a substance is of the same boiling point. Please note, how do we separate this? They said it has the same boiling point as water. Which of the following method would you adopt to obtain pure water? From sand and methanoic acid. To obtain what? Pure water from sand and methanoic acid. We have number 1. We have fractional distillation. Number 2, we have filtration followed by distillation. Don't forget that distillation is used to separate 2 different liquids altogether that has varying boiling, just a little difference in varying boiling points. While fractional distillation can be used to separate when they have a little difference in boiling point. Now, what is our option that we're going to use here? Please follow up with me. Now, if I say fractional distillation, I can't separate this thing using fractional distillation because they are of the same boiling point. Thus, note, remember that I said fractional distillation can only be used to separate when the boiling points are very little variation in boiling point. So that is out. Option B said filtration followed by distillation. Filtration followed by distillation. Let me give you one thing that you don't know. When 2 solids are mixed together, we normally use all these different kind of, maybe they are going to use filtration, then distillation, then sublimation. Is when you have like 2 mixture or 3 mixture. But in this case, we have mixture of methanoic plus sand plus water. Now, how do we separate them one by one? Now, the next one that I have here is option C is neutralization with sodium hydroxide followed by distillation. Neutralization with sodium hydroxide followed by what? Distillation. Sorry, this sound is not there. They made mistake in the question. It is methanoic plus water. That is the question. So neutralization followed by what? Distillation. Thank you very much. Let me explain to you. If methanoic is mixed with water, altogether, methanoic and water of the same boiling point, the easiest thing to do, since this methanoic is an acid, and we say that I can separate methanoic from water due to they have the same boiling point, I can easily add sodium hydroxide to this methanoic. That is the first step. Add solution of sodium hydroxide to methanoic. If sodium hydroxide is added to methanoic, don't forget that an acid, when it reacts with a base, it forms salts plus water. So if I add sodium hydroxide to the solution, this methanoic will react with that sodium hydroxide, then it's going to form salt and water. Then the solution will contain only salts plus water. Now, if I have a mixture of salt and water, I can easily get this salt or this water, the salt and the water, we can easily get both of them out separately using distillation. But what kind of distillation can I employ here? That is simple distillation. I don't think you get what I'm doing here. See, so the process is, the first step is add sodium hydroxide neutralization by adding sodium hydroxide. Then the second step is now what? Distillation. So if you check out option C said neutralization with sodium hydroxide followed by distillation. That is a great answer. Option D said neutralization with sodium hydroxide followed by filtration. No. Esterification with what? Ethanol. So the option there is neutralization with sodium hydroxide followed by distillation. Let me take one more question before calling it a day. Now, we have a question here that said, let me try to, yes. They said, the order in which a mixture of sand, ammonium chloride, sodium chloride can be separated is what? I love this question so much. They said, what is the order in which a mixture of sand, that is how the search question in Jamb, sand plus ammonium chloride, NH4Cl, plus sodium chloride. Thank you very much for asking me this question. Even though you know that what your brain that you are using to ask me that question is somehow. I mean, one must be asking me this kind of question in Jamb, and you are expecting me to fail it. Now, sand, ammonium chloride, and sodium chloride. If you are given a question like this, don't bother yourself. Don't bother yourself. Then I Jamb, you are mad. Now, the process here is that what? You see, ammonium chloride and sodium chloride, both of them will dissolve in water. Ammonium chloride and sodium chloride, they are both, if I say they will dissolve, yeah, both of them what? Will both dissolve in water. Now, because of their dissolution of both of them in water is a problem. I won't be able to separate them if they dissolve. Now, sand will never dissolve in water. Now, what is now the first step? The first step that I need to do is that, okay, let me see the option here. We have sublimation, dissolution, blah, 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 blah. That's rubbish. Now, the first step that you are going to do in that case is that what? So the first step I'm going to do is that what? I'm going to sublime this ammonium chloride. If you want to eat it, so the ammonium chloride what? Will sublime. Sublimation first. Sublimation. Now, if ammonium chloride sublime, I'll be left with sand plus sodium chloride. Are we together? So the first step is what? Sublimation. So that ammonium chloride is sublime. I'll be able to get ammonium chloride first. I'll be left with sand and what? Sodium chloride in the mixture. Then the next thing is dissolution. Dissolution. Please note very well. Dissolution is not a separating technique. Dissolution simply means pouring water into the what? Sand and water. And sand and what? Sodium chloride. So that is what the next step is dissolution. So when I dissolve both of them in water, don't forget that sodium chloride will dissolve. This one will not dissolve. Now, if sodium chloride is dissolving, it simply shows that what? I can easily remove sodium chloride and that water by what? Filtration. Filtration can be used to remove a liquid solution with a solid. Why am I going to use filtration? Because if sodium chloride dissolves in water, the size of particle of sodium chloride and that of water is the same. So you know the difference between sodium chloride and water. So the next step I need to follow is what? Filtration. Then after filtration, you know I've been able to remove sand. I've been able to use sodium chloride. Then I mean, how can I remove this sodium chloride from the solution of water, from the solution, which is brine? To remove sodium chloride from water, what will you use? The next thing, you don't forget I said earlier, what we can separate sodium chloride away from water using evaporation to dryness. Evaporation to dryness. Thanks for watching this video. Please don't forget to subscribe to my channel and please like my video because your like really means a lot to my channel and it's going to help me out in doing analysis on YouTube. Please don't forget, and don't forget to carry on to continue with us. In my next video, I'm going to be uploading, I'm going to taking you on other topics in chemistry and also in physics. Thanks.